Hi everyone, it's Coach Fred here. So today we're going to be talking about systems of equations and the SAT. And this is going to be one of maybe 3 or 4 videos on systems of equations. They're really that important for algebra, and you'll see a lot of different types on the SAT. So what do you really have to understand? So today we're going to talk about the types you have and how to solve some familiar and unfamiliar questions. So there's 3 types. There could be more, but there's 3 that I'm going to talk about on SAT. Systems of linear equations, systems of linear inequalities, and systems involving a linear and a quadratic equation. We call those quadratic systems. Today we're going to focus on linear equations, systems of linear equations. All right, so what's a system? So a system of equations is a set of equations that have a common solution. Okay, and you've learned about systems of equations having common solutions. So you've actually solved them to find the common solution. The common solution is a coordinate point. Now, a couple of things. There are 3 things that can happen when you have a system of equation. You can get 3 different solutions. So that's important. So the two line equations, they can actually intersect. And you find that common point that makes both of the equations true. You find that point of intersection, and that's going to give you an xy. But that's not always going to happen because, as we know, not every question has a solution. So if the lines don't intersect, then you have parallel lines. So the lines exist. They're just parallel, which means that, okay, so let's talk about that. Parallel lines. That would be no solution. So we'll say 0 solutions. Or no solution. And that would mean that the lines have the same slope. Now you know that lines that are parallel have the same slope, and actually on this test, that's going to be important. That you're going to need. We're going to need to remember that if a system does not have a solution, so it's no solution, that the lines have the same slope. And a little bit trickier than that is when there's tons of solutions. We call that infinite solutions. There's an unlimited number of solutions. And that means that the lines are the same. So they're the same line. We actually in math probably call them coincidental lines, or the lines coincide. When they are the same line, they not only have the same slope, but they also have every point in common because they are the same. They're just not going to look the same when they're given to you. And you're going to have to figure out if they are. All right, so today we're going to look at some familiar. You learned, oops, that's unfamiliar. So you learned that to solve a system of equations, you had 3 methods. In Algebra 1, you learned about graphing. You could graph them. That would take a little bit of time and is not always accurate if you don't have a calculator or a computer. You could use substitution, and I normally use substitution if any coefficient to my variables is a coefficient of 1. And then we also have elimination. Elimination is where you add the equations together and eliminate one of the variables. So I actually tend to, when I look at the SAT questions, I tend to see if they are in standard form. And if they are, which means ax plus by equals c form, then I tend to use elimination. Looking at this equation, it wants to know the solution, so it tells me actually that there is one. I see the answers, that there is one. So, but it only wants me to find the value of x. And I'm going to do that. I'm going to find the value of x by I'm going to use elimination because, again, they are in standard form. So I'm going to multiply the bottom equation by 3. I'm going to do that because I want to make the x's have the same coefficient but opposite signs. I'm going to write the revised equation right under it. So 3x minus 30y equals 48. I'm actually going to just kind of put a thin line through that so it doesn't get in my way. And then I'm going to add the equations together. And that's going to eliminate x. X is going to get eliminated, and I'm going to get negative 34y equals 68. I'm going to solve by dividing both sides by negative 34. That gives me y equals negative 2. Okay, but my question is asking me to find x. So that's telling me I have to substitute that value back in. I'm actually going to pick this equation because it's a little bit easier. So I'm going to plug the 2 in, the negative 2 in. Anytime I plug a number into an equation, I want to put it in parentheses, especially if it's negative. And so you can see why, because now that I have that negative 10 times negative 2, which is going to make a positive 20. And then I'm going to subtract 20 from both sides. And so x equals negative 4. Don't try and do this in your head because that's what they're banking on. They're banking on that you're going to rush through this and make a mistake. But it's question number 5. It's the non-calculator part. This is not hard. You know how to solve this. And you don't want to make a mistake by skipping a step. Like lots of kids might skip this negative 20. I don't, because they could add 20 to the other side. So you want to be very, very careful when you're doing something like this. And so x would be negative 4. All right, so that's familiar. Let's look at an unfamiliar way of solving this. Here's an unfamiliar question to you. If xy is a solution to the system of equations, what is the value of x minus y? Well, you're going to want to, I know it, you're going to want to solve immediately. You're going to want to find xy. But let's look at the difference of what's being asked. In this question, you're actually asked for x minus y. And in the last question, you were just asked for the value of x. When I'm asked for a expression of the variables, I want to think about possibly just adding my equations together and not solving my equations. I know in algebra, we're told solve, solve, solve. All we do is solve, 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 no matter what. But that's not always the case. Looking at this, if I just add these equations together, and I noticed I had a 2, 3 here and a 2, 3 here. If I add those together, I'm going to get, here, I'll come down here, 5x minus 5y equals negative 20. Well, that's interesting because I can simplify those equations. I can just divide them all by 5 because it's an equation. And that gives me that x minus y equals negative 4. And I'm done because they asked me for x minus y. So this is something that you're going to have to consider when you're looking at a question that asks you to solve a system and it's asking for an expression. Now, you certainly can solve this, but I can already tell you it looks like it's going to take you some time. And what's the most important thing on this test? Time. You want time for the questions that are more challenging, that are they're going to take you a few minutes to get through, and you just don't have that luxury. So I want you to consider anytime a question asks you for an expression involving the x and y, see if you can just add the equations together to get to a point where you get that expression. All right, I'm going to stop there today. There are going to be 2 to 3 more videos on systems of equations coming up, so make sure you watch those as well. Have a great day.